data, and they need to respond in milliseconds. All of this while we maintain developer agility, we keep our applications secure, and we deliver new features fast. And we need to build applications that are reliable and resilient to failure. And that's a tough equation. My name is Gunnar Grosch. I am a senior developer advocate at AWS. Today, I want to talk to you about how we can verify that our serverless applications behave as we expect them to. I'm going to do that by showing what verification is and how to do it. And I'm going to show you several practical examples of verification for serverless applications. So this is a statement from the updated reliability pillar of the AWS well-architected framework. Testing to ensure that you can meet your availability goals is the only way that you can have confidence that you will meet those goals. And what this tells me is that even though we follow best practices, for instance, by using the well-architected framework, and we use services that are built for high availability, and we are really good at what we do, well, building modern applications that often are distributed by default, it is really complex. So we can't really gain that confidence in the application until we've seen how it behaves under adverse conditions. So we have all of this complexity. How do we keep moving fast and not break things? And we as an industry, we are usually quite good at reactive measures, like incident response, disaster recovery, and different testing methods like unit tests and integration tests. But verification, that is a proactive experimentation where we're able to verify system behavior. So verification tells us why it's important to explore different set of conditions and the impact those conditions have on something that we care about. So let me show you. First, we have the objective, and that is something that you care about, something that says that your system is available. For instance, page loads, number of clicks per second, processing speed, and so on. Different things that you care about. And the objective might be defined at a business level. For instance, I want 10 items added in cart per second. Or it might be a technical and tied to a service. Like for instance, my purchase API should respond in less than 400 milliseconds. And the objective that we set, it of course need to be measurable. So we might, for instance, track the number of items that our users add in the cart per second, and we then add 10 as a threshold. Or instead, we measure the purchase API, and we add the latency threshold we defined earlier, 400 milliseconds. And then we have the conditions, and the conditions reflect different type of events that could occur in our system. So what if there is additional latency to each API call? Will the API still respond in less than 400 milliseconds? What if there is a downstream service error? Will we still get 200 clicks per second? We often know how our application behaves while we're in the steady state, that is the normal operational state of our application. But adding these conditions, that's to show how the application behaves under adverse conditions. And with the objective, the measures, and then one or perhaps several conditions in place, we can then verify our system behavior. And looking at this from the perspective of a site reliability engineer, perhaps the objective then is the SLOs, and the measures are our SLIs. And the conditions, well, they are different type of events that could occur and could affect our system. So let's look a bit at these conditions. As I said, conditions, they reflect different events that could occur in our system. And this is where the chaos engineering part comes in. I can't really have a talk without talking about chaos engineering. So we can now add our chaos experiments as a condition to our system verification. And when we're working with verification, we're adding these conditions as a way to learn about how our system behaves. So it's really not about breaking the system. It's about learning, and it's about building that confidence, the confidence we can only gain by testing and learning how our application behaves. So let me show you some examples of conditions we can add. We have a very simple serverless application. It's a web service with an API gateway, a couple of Lambda functions, and that are retrieving or storing data in S3 and in DynamoDB in this case. And we have an S3 bucket that the client uses, for instance, for fetching static data. So we can then add errors, inject errors into our application. And that might be, for instance, errors that makes our application return an error code instead of the normal 200 response the client would get through API gateway. Or it might be that we're causing exceptions in our Lambda function to see how our application behaves then. We can create different type of errors that are security related by adding security policy errors, and different type of service configuration errors. And these are errors that we every now and then might introduce when we're deploying, when we're creating new features. So we can create these as conditions as well. Or if we're using the disk space in our Lambda function, for instance, to manipulate data or using it as cache of sorts, well, then we can introduce disk space failures as well by watching how our application behaves if the disk space is full, for instance. And we can create different type of downstream service issues. In this case, we have S3 and DynamoDB as downstream services, but very common is to have an API, a third-party API as a downstream service. So we can add different type of issues to those as well to watch how our application behaves under those conditions. We can, of course, create issues in regards to concurrency and different types of throttling as well. And then we have the primary or the most common experiment or condition to add, which is latency. We can add latency to our functions to, for instance, simulate how cold starts affect our application, or different type of runtime or code issues. Of course, we can add latency as a way to test integration issues. Once again, that third-party API, if we add latency to that. Or we can use it as a way to test our timeout values. The timeout values of our applications, they're usually okay while we're in that steady state, but what happens if we have issues, for instance, latency in our application? That's a good way to test those. And to create these conditions, we have some tools that we can use. And the perhaps most common ones are these: Chaos Lambda, which we can use with our Python-based Lambda functions, and Failure Lambda for our Node.js-based Lambda functions. So let's just look at how Failure Lambda works. So it is an NPM package for our Node.js Lambdas, and that we can easily install. And we configure this with the help of either parameter store or AWS app config. We then have several different failure modes that we can use. We can, for instance, add latency. We can create different type of status codes to, instead of returning a 200 response, we can return a 502 or 404 or other types of errors. We can create exceptions within our Lambda functions. We can do these disk space experiments, or we can use a deny list as a way to intercept and then deny network calls to downstream services, be it AWS services like DynamoDB, or perhaps more commonly use it with our third-party APIs to see how our application behaves. And it's fairly easy to get started with. We wrap our Lambda handler with it, and then we're good to go to use it. And then we set up the configuration for it, which is done through basic JSON syntax, and as I said, stored in the parameter store or by using AWS app config. All right, so back to our verification process. So we now know a bit about how we can add conditions to the process. So let's look at some practical examples of verification. So in this example, we have a simple serverless web service. It's a client calling API gateway, which in turn invokes a Lambda function who retrieves or stores data in DynamoDB. So first off in the process, we have the objective. And the objective in this case is my purchase API should respond in less than 400 milliseconds. So business or a technical metric in this case. We then set a measure, basically set up 400 milliseconds as a threshold and use that as a way to measure if we are following that objective. And we then add our condition. In this case, we're going to inject 100 to 200 milliseconds of latency into our function. So for each invocation of our Lambda function, we will get an additional 100 to 200 milliseconds of latency. And then we're able to verify that part of our application. We can then verify to see if it passes verification or if it fails verification. So that's one example of how we can add conditions to our verification process. And in this case, by measuring the purchase API. Next one, we have the same simple serverless web service. And in this case, we have a business metric. I want 10 clicks per second for this web service. So we set up a measure, 10 clicks threshold. We, of course, need to be able to measure our clicks and then set that metric. And in the condition in this case, well, let's inject a downstream service error into our application. And that might be on each invocation. It might be on just parts of the invocations, and then to test how our application behaves. And in this case, perhaps more importantly, see the user behavior based on that condition that we add. So then we're once again able to verify, did we pass or fail our objective when we added the downstream service failure into our application? So those are two different examples of how we use conditions as a way to verify our system behavior. So the question then is, where should we do this verification? Well, you don't have to do it in production. Just to be clear, you can do it in test, you can do it in dev environments, you can do it in staging environments, and so on. The more production-like, of course, the better. But many of these tests, they are great for verification of behavior even in test environments as well, to see that we've built the application in the way that is according to best practice. We have different type of graceful degradation and so on. We're using queuing and so on. All right. So we've now looked at verification, and now I'm going to look at part of an evolution that we're seeing from CI, continuous integration. CI limited the number of bugs that we can create by merging code faster. So the bugs that we do create, they become more apparent, and they don't geometrically lead to larger number of bugs. So the engineers can now create features faster. All right, so now that we can make software faster, that involved into CD, continuous delivery. We needed a way to get our features into production faster and to be able to roll forward faster. And the next step from that then is to do the type of verification we just looked at, but in a continuous way. With the type of complex systems that we build, we need to have this as a continuous process to be able to verify our application as we're delivering new features to the application. And that's what we call continuous verification, or CV for short. All right. So with the same simple web service we had before, we're now adding on our delivery pipeline. In this case, we have AWS code commit, code pipeline, and code deploy. That's a fairly standard way of delivering code into our serverless applications. But you could, of course, use any type of CI/CD platform for this. And instead of inventing this as a new type of service and adding it somewhere else, we can use this process, the ones that we usually already have in place, and add the verification to that. So let me show you an example. In this case, it's the same basic web service, but with our CI/CD pipeline in place in front of it. We have the same objective. The purchase API should respond in less than 400 milliseconds. We set our 400 millisecond threshold as a measure, and we then add our condition. But instead of doing this as a one-off manual process to add this, we're adding it as a step in our deployment process. So the experiment or the condition, that's added there. So we're enabling this as part of our deployment, and we're then measuring the result of that condition added to then be able to verify the application during a set amount of bake time that we're waiting for the result of our verification. In this case, it passed verification, so we're then disabling that condition, removing that, and we now have a new feature that is verified, delivered to our users. Let's look at another example. Same pipeline, same web service. And we're using the same objective, respond in less than 400 milliseconds. We have our measure in place. And now we want to add our condition. But the blast radius of the condition we did before, it's quite large because we're adding that condition to all users. Now instead, let's add it as a canary deploy. So instead of having that condition on all invocations of Lambda, we can add it to, for instance, 10% of invocations. So 10% of invocations will get that condition added, and we're then able to verify on that smaller blast radius if our application behaves as intended. In this case, it's a latency that we're injecting, but think about all of the different conditions that we could add in our application. And having that on a smaller blast radius means that we're able to see it without actually affecting all of the users in the platform. In this case, verification failed. We saw that users weren't getting a response from the API within less than 400 milliseconds. So instead of continuing with the deploy, we're rolling back the deployment. So users will continue using the older version or not the new feature with the condition added. So a third option as well. This is perhaps my favorite. So same service, same pipeline. We have the same objective, still want to have the purchase API respond in less than 400 milliseconds. We set up our measure, and we add the condition. But in this case, we're going to do it with the help of feature flags, because using canaries means that even though we have a smaller blast radius, we don't have control over which users will get that condition added. Because we have a stateless application, we don't control which of the 10% will get to Norway or which will get to Sweden and so on. But using feature flags, we're able to then enable these conditions on specific users, for instance. So if we want to add this condition to users from Norway only, well, we're able to do that with enabling it as a feature flag, but still as part of our delivery pipeline. So it's a continuous verification of our application. In this case, when we've done our verification, we've seen that it passed. So that's great. We can then remove the condition, but keep the new version in place. And then we have new users rolling over to the new application. All right, so some key learnings from this. Pretty quick overview of continuous verification. Verification tells you why it's important to explore a set of conditions. And it's really not about breaking things. It's about learning, and it's about building confidence in the system. And it is quite easy to get started. We don't have to look at chaos engineering and continuous verification as this big obstacle to get to. We can get there quite easily. And I want to leave us with this. Testing to ensure that you can meet your availability goals is the only way you can have confidence that you will meet those goals. So today we looked at how we can verify the behavior of our serverless applications through verification and by adding conditions. And this allows us to learn, build confidence, and in the end, create more reliable applications. My name is Gunnar Grosch, and thank you very much for joining today. I think you're muted, Zamira.
Oh, thank you so much, Gunnar. Thank you so much. I'm so sorry, guys. I'm having some problem with the systems and I was not able to join. So thank you so much. Excellent presentation. I really enjoyed. And we lost this the first part. I wanted just to thank everyone and to welcome to our session of Amazon and AWS Communities Hero. So but before go to that, I want to ask you only two questions. One question is about, so when should we start thinking about using verification for our application?
I think it's something that we should start thinking about quite early on in the process. Building applications that are as complex as many of our applications we build today are means that we need ways of knowing how it will behave. So I think thinking about adding these perhaps not continuous verification, but at least verification of applications early on, I think that's a great way to make sure that our application behaves as it should. Think about the scaling that you might get in your application when you're adding more and more users. So adding it early on, I think that's the way to go.
Oh, that's a great answer. Thank you so much. And I have another question also. So how much added time and effort it is used for the technique in general?
Well, if you add it as part of the day-to-day work, it shouldn't really be that much added effort. If you have it as part of the way you deliver features today, it should be a smaller addition to the work you actually do. And thinking about it as a proactive way of verifying applications means that instead, perhaps you'll remove the part where you have to spend time fixing failures, fixing bugs, and so on instead. So in the end, hopefully you'll save time by doing it.
Okay, that's great. Thank you so much, Gunnar. I don't see any other question in the chat. It was definitely a great presentation. I really enjoyed and learned new things. So thank you so much.
All right. Thank you very much.
Thank you. We are going to do a small break and see you for 4:30 for the next speaker.
Hey, Zamira, good afternoon. I think you're on mute. I can't hear you at least.
Hi, Marek, and welcome. We are in the
Hi.
second speaker now, so welcome, Marek from AWS. Marek is going to talk today about serverless application CDK, so building how to build the serverless application. So welcome again, Marek, and I will hand over to you.
Yeah, no, awesome. Just Zamira, you can see my slides right now, right? Just to make sure everything is correct.
I'm going to add you as well, please.
Okay, great. All right. Hey, let me then start with, while you're figuring out the screen, let me start with a very short introduction. So my name is Mark Kuczynski. I'm a senior serverless solution architect at AWS. So this track is I know about from Amazonians and heroes. I'm definitely not a hero. I work at Amazon, right? But I work with actually a lot of the folks that are organizing this conference today. So it's in that sense a little bit like a reunion as well. Very nice to see, Walter and Zamira and Martijn as well organizing this. So, we're still staying close, even though we're all at home. And I've been actually within AWS working for around 4 years right now. In this last year, I've been working purely on serverless. So what that means is that I work with, our big customers and our small customers on basically adopting their serverless journey. That can be through training, that can be through feature requests, that can also be by helping them with their serverless architecture. So in case you're actually watching this stream right now, and you're maybe also starting with your serverless journey, or there's particular issues that you might be having, you can either drop me an email. So my email address is written here, and I'll reach out to you and help you. You can also send me a DM or follow me on Twitter on the alias that is shared here as well. So, in that sense, looking forward to also get to know you a little bit better. In the presentation now, and I'll really try to stick to 20 minutes, I'm going to be talking about serverless applications and how you can build them with the CDK. And the reason for that is actually that the CDK is one of the most exciting infrastructure as code tools, in my opinion, that we have released. I also see a lot of momentum actually with many of the customers that I work with. So really the intent of this session is to kind of inspire you and hopefully, also encourage you to actually start looking at the CDK. So let's get started a bit. And what I'll do as a start is just give you a bit of an overview of what some of the maturity levels may be whenever you start working with infrastructure as code, right? So the idea behind infrastructure as code is really to automate as much as possible of the infrastructure ops that you have. And infrastructure in this case can really be EC2 instances, Lambda functions, containers, or basically anything within the platform, right? So towards the end, we'll focus a bit more on serverless, but basically this talk applies to pretty much whatever else you might be building on AWS as well. And kind of like the first level, or the lowest level of maturity, maybe I should say, whenever you start, working maybe on your applications, is what we call level 0, right? So kind of the easiest way to build applications on AWS is just creating infrastructure by hand. So just by the beloved console, where we just kind of, click on all the infrastructure that we need. The problem a bit with actually this type of manual approach, to maybe clarify it a bit, is that this doesn't really scale well, right? So if we have maybe one developer, that developer can do a pretty good job on actually figuring those things out in the console. Whenever you start having 2 people, 5 people, 10 people, or whatsoever, this will become really messy to actually manage infrastructure by hand. So, already for years ago, people started figuring out that this was a bit of a problem. And kind of the first approach that people started taking, which we call level 1, is to use simple scripts to just basically automate these operations, right? So instead of going into the AWS console and managing things, you could create a script in PowerShell, in Bash, or maybe another language. That script will then talk to the AWS SDK. And in that way, you can also create then your infrastructure, right? So kind of the downside of that is, even though it's a step forward compared to maybe doing things manually, the downside is that there's a lot of, unnecessary code. So you're maybe going to be writing, massive scripts with if then else conditions. There's also a couple of problems with, kind of things like race conditions, or maybe if 2 people try to run the script at the same time. You're basically in this way, it's a step forward compared to manual work, but you're still doing a lot of the operations on your own, right? So there are still more levels coming where we will show you how you can actually take a better approach with that as well. So level 2, as we call it here in this presentation, is actually where you're using a more tailored tool to create your infrastructure on AWS. And I've listed just a couple of examples here. These are not all the tools that are available for this. But you can think about, declarative infrastructure as code tooling as being, for example, CloudFormation or the serverless application model, which I'll show you a little bit more about. That's more tailored towards actual serverless development on AWS. Or you could even use a third-party module such as, for example, HashiCorp Terraform to also manage and create your infrastructure. Now, the difference really between scripting and using a tool like this is that we already use more, we already have more abstractions available in the templates that we create, right? So the templates could be in JSON, could be in YAML or anything else like that. But just to give you an example of how, for example, this could look with CloudFormation or with the serverless application model, they are very similar. Not going to talk too much about them now, but feel free to drop me any questions if you have them. This is an example of how such a template could look like. So, unlike with the scripting approach, we can actually go ahead and define resources here. You see that there's also a block about where we define actually the Lambda function, right? It's called the serverless function over here. And you can kind of, without studying this too much, you can actually kind of read a little bit what the gist is of what this infrastructure as code template would do, right? So it's in that sense significantly easier and has a couple of very meaningful abstractions as well. One of my favorite abstractions is actually the one that you see on the bottom, right? So the bottom 2 lines where you see actually list table and where you see also AWS serverless simple table being created. It would only take me on, the cloud, on the serverless application model. It would only take me those 2 lines of code to create a DynamoDB table, provide it with some capacity. And, from there, of course, I could go ahead and start modifying it further in this template, right? So that's really where the power of these type of tools come in. Now, of course, we're not stopping at level 2, right? So there's also going to be, or let me actually first show you a little bit of a picture before I kind of talk about the main course of today, right? The CDK. Just to give you a bit of a picture in case you maybe have never used these tools. Whenever you're using CloudFormation or AWS SAM, which is that serverless extension I just talked about, basically what happens is that, the tool will create CloudFormation for you, right? So that's also the logo that the little squirrel, the mascot, is holding. You always kind of use these abstraction tools to compile basically CloudFormation. And then underwater, actually, that CloudFormation template, which might be, hundreds or thousands lines of code, will automatically be created and will create your infrastructure in such a way. So where, for example, SAM really shines, in my opinion, is especially if you're using the services that are listed on this page, right? So if you're kind of like in that sweet spot where you're using kind of purely serverless services, if that's a thing, but you get a little bit what I mean, DynamoDB, Lambda API Gateway, then this is actually a fabulous tool and probably the one that I actually develop with most as well. So let's talk about now actually the main course, right? What is actually the Cloud Development Kit and how can this kind of be a meaningful addition also to some of the other toolings and strategies that we've been talking about. So what happens with the Cloud Development Kit actually is that, we're still interested in creating infrastructure, right? So we're still using this to create applications. We're also compiling actually code towards CloudFormation, and that CloudFormation will actually talk to the SDKs, as you see a little bit on the bottom here of the slide. But the real main difference here is actually the programming interface, right? So kind of the thing that is closest to the developers on the left side. Instead of having to learn, a specific language with a particular syntax, we can actually now start using regular programming code. So what does that actually mean? You see here a bit of an overview where I've combined both the infrastructure definition code, right? So something that's either Terraform or CloudFormation could do, but then in the CDK flavor. And on the bottom, you see an example of a Lambda code, right? This is just a very simple Lambda. It's kind of like a hello world one, which just says hello from The Hague, where I live. But kind of like the takeaway message here is that, we can, if you focus on the top part of the screen where we actually define the CDK application, you will see that this is a standard Node.js code, right? So I don't need to learn a YAML syntax or a JSON syntax or whatsoever. I can use the programming language that I already know to actually start defining the infrastructure as I want to do it. The other benefit that we'll see also in a minute is that actually, besides being a bit more familiar for developers, so, if you're maybe been developing in Python or Node.js or Java for a long time, you will actually see that this is a lot easier for you to pick up, as I'll also show in my demo. But some of the benefits as well here is that actually there's a lot of different type of constructs available. You'll hear me say that word a little bit more often, but a construct basically means kind of like a programming class, right? So a function which can kind of extend one line of code towards actually, either one AWS service or sometimes even a full architecture, right? So this is really, again, about accelerating basically the development speed that you might have whenever you start creating your applications on AWS, right? The whole idea behind the CDK is to limit kind of the time that you need to spend on defining and maintaining CloudFormation templates or any other infrastructure templates, because that's at the end of the day not really what matters to your customer, right? What matters to your customer is that you're developing the application and not managing the infrastructure. So with that being said, let's talk a bit more about what actually a construct is, before we're also going to dive into a quick demo. So a construct is actually, this is kind of the most powerful example, in my opinion, of what a construct can do. In this case, what we're actually doing is we're specifying with one line of code in the CDK language. In this case, it's in TypeScript. We're specifying that we want to have a VPC with 2 AZs, as you can maybe see in the command as well. And what this command will actually automatically do for us is deploy all of the necessary infrastructure that we may need in order to create a VPC. So, without going into too much detail, there's things like subnets, ACLs, router rules, maybe a couple of other particular things in there. This will actually expand, this just one command will expand to 270 lines of CloudFormation code, right? So again, this is an abstraction for CloudFormation. So you need to basically focus only on the CDK code, and we will take care of the magic to translate that into CloudFormation. This CloudFormation code is not something really that you need to touch or to inspect. You can always do so, right? So it can be kind of like an escape hatch, or in case you're maybe debugging a more complex problem. But in principle, you can always stay, whenever you're using the CDK framework, kind of in CDK land, right? So kind of in the nice and simple abstractions that you see on the top. Now, before I give a super quick demo about this, just wanted to also highlight a bit that, one of the reasons that I'm actually excited about this is that the CDK can actually be used by a very broad set of developers as well. So you've seen Python and TypeScript examples of me already. You can also use actually Java or .NET to create and define the infrastructure as well, right? So irregardless of what kind of your strongest programming language is, or maybe the one that your teams prefers most, if you're using any of these 4, you will see that actually you can adopt CDK and start building infrastructure in this iterative way in a pretty quick and easy way. So let's switch to a very quick demo just to give you a bit of an idea of how actually the CDK works and how you can actually get started with creating your own infrastructure. So the first thing you're seeing over here, just my Visual Studio Code screen. So I'll just show you a little bit how you can do this from scratch. And one of the first things that we could do actually whenever you create our infrastructure is to, I have an empty folder here, by the way, just so that there's no cheating. But the first thing that we would actually do whenever we create a project is to run the so-called CDK init command, right? So that stands for initialize. And that's actually where we will create kind of like the bootstrap templates and all of the necessary code in order to create our CDK project. So if I run this for Python, right, it could be for Java or Node.js or any of the other languages as well. There's going to be a couple of commands and a couple of things that are being shown, right, for useful commands that I can run. There will also be initially a couple of files, as you can see on my screen. Let me make it just a bit bigger. A couple of files that are created for me. So a README, requirements file, cdk.json. I don't really need to worry about those yet, right? So what kind of the main important file will actually be that I wanted to show you as well is the so-called stack where I can actually start editing my code, right? So I'll just expand this a little bit to give you a bit of an idea. This is kind of the code that CDK has already created for me, right? So you can see that it's kind of created a class for me and a couple of other kind of bootstrap code. Now, what I can start doing from here is I could just show you how I can actually start defining, for example, a Lambda function or any of the other components that I might need. So we have already the core library included. What we also want to have, and this is where actually why I wanted to show this very quickly in a live demo as well, sorry for interrupting, is just the fact that this works beautifully actually with Visual Studio Code, right? There's also a couple of other IDEs that you can use with this. I use Visual Studio Code myself. And one of the huge benefits of this is actually what you see happening on my screen right now, right? So if I want to define maybe Route 53, right, which is, as we heard in the keynote, Corey Quinn's favorite database, I could just go ahead and import the Route 53 class or Lambda or S3 or virtually any imaginable AWS service can be added in this type of way, right? So I'm not going to use Route 53, so I'll remove it for here. But in this case, I want to have, for example, Lambda. Now that I've taken care of the importing actually of the necessary CDK code, I could go ahead and just start typing a function, right? In a very similar way that I would write my code in regular Python, right? So I will go ahead and, for example, define that there's going to be an AWS Lambda. I will also define that this is going to be a function. I then happen to know that I need to, reference it to self and give it just a friendly name, for example. And then actually over here, since these are kind of like the main things that I actually need to define, I can just go ahead and kind of through my IDE, as you see me do right now, start exploring a bit what the various options are that how I can actually start defining my infrastructure and where I can start making modifications. So what I'm doing, for example, now is just adding the folder. Oh, sorry about this big pop-up. The folder, for example, where our Lambda code might be stored, right? So it might be maybe locally on my machine in the Lambda folder. We also need to, for example, specify, for those of you that have worked a bit with Lambda before, a timeout, for example, or sorry, it's actually we need to specify, first of all, I see what's going wrong. I had an extra semicolon. We need to specify, for example, the handler, right? So the handler will basically be the starting point where our Lambda function will start. So I'll just do it fictionally, maybe call it Lambda handler or something like that. And then, for example, something like a timeout, right? So we also want to maybe ensure that our Lambda function actually has a timeout, right? We don't want the Lambda function maybe to run too long or something like that. So we could actually go ahead and define that using core duration. And then we can do, for example, seconds, or we could do minutes or anything else like that, right? Since I'm running a little bit short on time, I'm not going to finish the whole example, right? I just wanted to show you a little bit firsthand how the developer experiences with this, and that actually the client-side tooling can have a huge impact. So if we save this right now, I'll just spoof really quickly, create an empty folder where we kind of trick CDK a little bit in thinking that there's a Lambda function here. But basically what we could start doing right now is to actually use some of the CLI tooling as well. Oh, sorry. To see, for example, if our stack is actually running valid, right? And again, I'm trying to stay within the allocated time, so I just going to show you a little bit how you can start debugging. For example, what the function will tell me right now is that I didn't specify a runtime yet, right? So the way that I often develop this is exactly the same way that I'm showing you right now. I will just start typing some code, kind of from the top of my head, create a Lambda function, create a bucket, create a topic, a queue, or whatever, and then kind of use the CDK tooling, right? Use the top of my screen to kind of start defining the code, and then the bottom of the CLI to basically run either a lint checker or the CDK tooling to see, for example, if it works. So in this case, it's actually warning me that I forgot to specify the runtime. So I could go ahead, and you're seeing how quickly I'm doing it just with autocomplete. I specified as being Python 3.8, right? So now if actually I run something like a list, I still get another error. I'll skip a little bit over the right here. I'll link to my fully working GitHub demo where you can actually find a bit more examples. But another use case where I would kind of put in a call for action for you as well, if you want to learn more about the CDK, right? I could only give you a very short glimpse in this short period. There is actually a very useful CDK workshop that you can use. You can find it at cdkworkshop.com. And in that workshop, actually, within 1 to 2 hours, that's the average duration that it takes, you will actually learn how to create a very simple serverless architecture. So it will be an API gateway and a Lambda function. So kind of like a very simple way to create a RESTful API on AWS. And just as with the CDK, as I was showing you before, you can actually complete this workshop in Java, .NET, Python, or TypeScript, right? So no matter what kind of your background is and what your strongest programming language is, in order to create something a bit more complex than I was trying to show in like 2 minutes in my demo, you can take a look at CDK Workshop and definitely follow it there. Now, I have like around a minute left, so I want to just make a couple of short call outs as well on where you can actually look and what some of the other reasons are that actually a lot of customers and myself are very excited about the CDK. So One of those things is, for example, that from AWS side, we actually started creating so-called solution constructs. You see a couple of examples here of constructs, but basically what this comes down to is, being able to do more than just one. We actually deploy here kind of like mini architectures or kind of building blocks where, for example, an API gateway and a Lambda are included on the left side, or a DynamoDB table, and for example, that sends data towards a Lambda function on the right side, right? So these are even higher level abstractions that allow you to code even less than I was already showing you in my demo, right? There's also, a lot of actually community-driven patterns that you can find. So you can take a look, for example, at cdkpatterns.com, also a couple of GitHub repositories where you can actually, in some cases, find complete architectures or, something maybe like an Angular or a React project that you can also in a very quick and easy way start developing. That's what I wanted to share about the CDK itself. So we'll get over to the Q&A in just a minute. I still wanted to take kind of the opportunity to also give a bit of a shout out to the community actually that I'm very close with as well, right? So I've been a regular speaker and contributor with the AWS user group, who is of course, doing an amazing job today at organizing this event, but wanted to also put your attention that, in case you're interested about serverless, take a look at the Serverless Day meetup group as well, right? So this is a meetup group that's being organized from Amsterdam, although as we're all stuck at home, location doesn't matter right now, but we still call it Serverless Days Amsterdam. So, take a look there. We organize meetups roughly every month. And actually on November 4th, we will have a couple of speakers as well, including an AWS hero. So we hope to actually see you there with our event as well. And with that being said, I'd like to thank you for, for attending. I see that I went 60 seconds over time, so not too bad for me, who I usually talk a lot more. So, thanks again for attending the talk, and wanted to check in actually with Zamira if there's any questions or anything else that I could cover.
Well, thank you so much, Marek. Your presentation was definitely very great. So I really enjoyed so much, especially your demo. Myself, I use Visual Studio Code. It's very, very good tool that helps you to develop your application. In your case, it was a really good demo showing how you can deploy application using CDK. Yeah, I'm very curious, and I have two questions for you. So the first question is, so from your experience, and you are from AWS as well, what should be the good tool to deploy serverless applications? So should I use CDK or should I use SAM? So what are the pro and cons, let's say, for between these tools?
Yeah, no, absolutely. That's a great question, and something happy I can clarify it a bit more as well. So, why don't you maybe start off with a bit of a comment? So even though I called it kind of level 0, 1, 2, and 3, there's nothing wrong with using a tool that's maybe at level 1 and level 2, right? It's very dependent on how big is your company? Is it a production environment? Is it a test environment? So, by any means, don't take kind of the guidance that maybe I give you or other people from AWS as being kind of, I must do this. But with that disclaimer being said, what I personally actually do, and you can take a look, for example, at my GitHub or some other talks, I probably use both SAM and CDK equally by now. So whenever I'm developing something that's really in that serverless sweet spot, so, I'm using an API gateway and a Lambda and a DynamoDB table, then actually SAM has kind of the benefit for me that, I happen to know these abstractions that are in YAML by heart, right? That short example that I had with 20 lines of code. I can kind of type it in my sleep. It's very predictable. And there's also actually, contrary maybe a little bit to CDK, there's a couple of other unique capabilities that SAM can do. So for example, you can do local testing and local building of your Lambda functions a little bit easier, right? That's all built in. With CDK, you can do those things as well. But that part will actually still to this day take a bit more work in my experience, right? So SAM is definitely, even though I called it level 2, still kind of like one of my weapons of choice. I would use the CDK, and where I see kind of the CDK is growing quickly in popularity, is basically for, both serverless, but also anything else on AWS. So what I quite frequently see working with customers is that, not everyone can or wants to use kind of like only that serverless sweet spot, right? So there are definitely cases, and I know, Zamira, you have that in your daily job as well. Sometimes you need a relational database, or, I hope sometimes you might even need an EC2 instance, which for me is, of course, a very strange concept as a serverless solution architect, right? But without kind of kidding, CDK would allow you to deploy, I think, virtually everything on AWS. So it could be IoT, it could be databases,
this
or
is my
VPC
follow-up
as
question. Yeah, this is my follow-up question. So basically, yes, some has some limitation, right? I can deploy application or serverless application, but what I can do really with CDK, can I deploy only a serverless application, or I can create the whole infrastructure in AWS, including other services as well?
Yeah, you could actually, first of all, you could do, I think, virtually everything. Every AWS service that has an API or CloudFormation support can be created with it. So I've seen actually one of the interesting customer cases that I've seen is customers actually using it to, for example, create IoT rules and like IoT functionality, which Sam wouldn't be able to help you with. The other interesting thing that's maybe worthwhile highlighting as well, it wasn't really the focus of my talk, but people are also writing, first of all, a lot of their own constructs for CDK. So there are, for example, one of the very famous examples there is a company called Liberty Mutual, who also organized CDK Day and a couple of other events. They have, for example, with CDK, a whole catalog actually of ready-made applications, right? So what they actually do is if they need an API or a data lake, they just kind of take the construct off the shelf, they embed that, and within the first 5 minutes, they already have kind of the framework. So you can kind of imagine how quickly they can develop with that. The other thing that I wanted to mention as well is that we also see CDK actually being used, for example, to define or kind of configure things like, for example, Kubernetes clusters. So there is a specific Kubernetes extension, for example, for CDK, where what's quite interesting about this, and this should appeal probably to people that are using containers a lot, that you can then use the infrastructure and also the Kubernetes configuration within one tool, right? So I could talk for this for a very long time, right? I think we need to wrap up in just a minute. But the CDK is very broad in that perspective as well. If anyone has questions, feel free to DM me, send me an email, and I can talk for hours more about this as well. But I think we need to probably wind down.
Yeah. So thank you so much, Marek. It was a very, very wonderful, wonderful presentation.
Thank you.
And definitely you can reach Marek in social media if you have any questions. So I don't see any other question in the chat. So thank you so much, Marek. See you so much. See for the next presentation. Welcome, James.
Hi, Zamira.
Another Amazon guy. I really can't wait to hear your session because I'm completely new to this service and I'm really curious. So James is going to talk today about building event-centric serverless application with Amazon Event Bridge. Myself, I don't have experience. I'm very curious to know everything about this. And hopefully I will have a lot of questions for you in that. So, yes, I'm hand over to you, James.
Great, thanks very much. Do you see my screen?
Yeah.
Okay, thanks. Well, thanks everyone for joining us today for the AWS Community Day in Amsterdam. It's really a pleasure to be here and talk to you about Amazon Event Bridge. My name is James Bezic, and I'm a serverless developer advocate. And before I was a DA, I was a software developer for many years and also a product manager for a very long time. I've been a self-confessed serverless geek for quite a long time and spent many years building applications entirely from serverless. The most important thing on this slide is my email address and my Twitter handles. If you have any questions at all about serverless, Lambda, Event Bridge, or anything else after today, feel free to reach out to me anytime, and I'll do my best to help. So we're going to cover 3 things today in 20 minutes. First, I'll talk about the challenges of using microservices as we've moved from monoliths. Next, I'll explain how an event bus like Event Bridge can help solve some of these issues. And finally, I'll take a look at how the service works and how it fits into some of the concepts I cover in the first section. I'll give you some additional resources too, so you can explore this service after the session. So let's talk a little bit about some of the challenges associated with building these kinds of distributed systems. The first thing I want to talk about today is coupling. One of the big benefits that's often cited with microservices is that often these services are loosely coupled or decoupled. But it's important to recognize that anytime you have 2 systems talking to each other, there's some degree of coupling happening there. And you need to understand the long-term ramifications of that for your system. This is a standard synchronous API. I'm sure we've all written plenty of these. And in this example, a client comes in and posts an order to an order service, which turns around and posts another request to an invoice service, which then does some work, and then it returns a 201, maybe an invoice number as well, and that gets returned to the client. And so you take a very simple example like this, and you just have 2 services, and there's no monolith at this stage. It's actually just very simply 2 separate systems. But what happens when we add more and more services that integrate with the order service? What starts to happen is the order service gets more responsibilities and more complexity. And the order service has to understand things like retry semantics for each one of the services, and maybe bundle an SDK for each one. Even if downstream publishers have an API, it becomes on the order service to integrate the API into this overall system. And if there are any backwards incompatible changes to the APIs, again, the order service team is on the hook to update this. So long term, there are more and more services out there that need data from the order service. And in this model, the teams end up being blocked by the order service team to implement these changes. And they cannot operate independently as they once could. So it creates unnecessary friction in the process due to the integration cost of hooking these services together. And that slows down the development process. So when you get to this stage, the decoupling has gone, and now we're back to working with a monolith. And it's a really common pattern, systems starting off in a decoupled way and trending back towards being monolithic. So what can we do about this? Here's a second issue. As APIs develop into complex workflows, it can be difficult to make sure that each service has the right state. So here's the same e-commerce application with some additional downstream services. I've added fulfillment and shipping. In the happy path, everything works as expected. The order service triggers the invoicing, payment, and forecasting services. And then once the payment clears, that triggers fulfillment. Then once that happens, that triggers shipping. But what happens if the fulfillment service cannot find a product because it's not on the shelf and they're out of stock? So now the fulfillment service has to tell the order service that it needs a modification. Maybe it then has to send a message to reverse a payment or issue a refund or a partial credit. And the shipping service may have already been told, so they have to send a message back to the invoice service as well. And then the forecasting service may not accept these kind of modifications, so it could just be broken until somebody makes a manual change. So this is just the remediation path for one possible thing that could go wrong in just one of the services. Now here's another one that happens fairly frequently too. Imagine your team works on the payment service, but you weren't told that another service, a reward service in this case, was added. So what happens now when the fulfillment service errors as before? Maybe the fulfillment service orchestrates all these other services as we saw, but the reward service team never finds out. And the end result is that a cancelled order ends up with a reward for a customer, which definitely wasn't the intention. Also, what happens if the reward service changes vendors, maybe adds another API? Does your team know about this, with an old service pinging a new one to keep it in sync? So ultimately, it's really hard to keep these sorts of systems orchestrated and in sync because of the complexity when you start to add more and more services. Here's one more issue. Let's talk about availability in these systems. So back to our ordering system where the team is managing payments. There are a number of potential problems here. The first is performance mismatch. It takes longer to process payments than it does to send invoices. So in busy periods, your slower performance is holding up the order service and the customer is experiencing delays. In synchronous APIs, putting a fast service in front of a slow service can tend to lead to a lot of problems. The second issue are outages. So if the payment system goes down, the order service also goes down. So the availability numbers for the total service are worse because these systems are interdependent. And the downstream failure appears as a total failure for the end user. So how can events help with these three different challenges? Well, first, what is an event? Well, in its simplest terms, an event is simply a signal that a system state has changed. It's often represented as a JSON object, and it contains some set of facts about the event or the change itself, and potentially the new state of the system. Events typically have certain attributes, so they may be facts, for example, and they're immutable, they don't change. They're observable, and they're temporal. The time of the event really matters to the system. And we're really interested in the fact that they're observable instead of being directed. So what does this mean? Well, in a command model, commands are explicitly issued to a specific recipient. So in this example, the person on the left says to the person on the right, please create me an invoice. And this is a directed command. In an observable system, the person on the left says customer X just ordered a widget. And with 4 people listening, one decides to add that to the sales report, another decides to send an invoice, and 2 to take no action at all, even though they hear the event. And this is a subtle difference, but a really important one, that event producers don't need to know about who's listening to the event. And this keeps them very simple and allows other services to consume events without needing any upstream changes. So how do we actually implement this? Well, how do we pass information from this order service to all of these services downstream without actually calling them directly? Well, for that, we need an event bus. And this provides an endpoint where an event producer can send events. The router manages directing and filtering those events to the appropriate downstream consumers. And consumers can get the events they care about, and they can do this reliably while the producers remain completely decoupled. So our architecture now looks like this. The order service sends events to the bus, which is configured with rules which determine which downstream systems get the events. Some targets will only care about certain events, others will want all the events. But either way, the router now takes on the complexity of ensuring that these events get propagated appropriately to each downstream service. So back in our example with an event bus decoupling the architecture, it actually looks very similar. But if the fulfillment service raises an error as before, they simply raise an error event. And this is caught by other services that are listening, and they can then take action accordingly. Now, in the other problem example I talked about, where a reward service is added, for another team to consume some of the order service's events, they just need to add a new rule to the bus. There's no need to wait on the order service team to make an integration or any kind of update for them. So these service teams can now act more independently and move faster. So as your applications expand to include other systems beyond your immediate control, you need to pass information to and from those services. Since you don't own the code, it can actually be hard to get that information out of those systems. And we've got a couple of different ways traditionally to do this. The first option is polling. So in this case, you might have something like a Lambda function that's triggered every minute to query a service, and that then generates events based upon that information. Now in this case, this is generally okay if the payloads are not too large, but it tends to be a last resort option because there's an unnecessary lag between data becoming available in the service and you knowing about it, and it creates unnecessary load on the API due to the number of empty calls with no information coming back. You also have to manage this polling service. The second option is webhooks. This is a much better option generally, but only if your SaaS provider supports the idea. You provide the SaaS provider with an HTTP endpoint, and they post or get information as it becomes available. You can use a custom authorizer to validate the calls, and now the data you're getting is much closer to real time. But there are some problems with webhooks that people commonly don't think about. If your service goes down for any reason, you may lose information. It's possible the SaaS provider doesn't have any retry logic to call you again. These endpoints are internet facing, so you have to secure those and write custom authorizers. Often the security model here can use static secrets like API keys, which isn't really the best approach. And you have to manage this API, and of course you have to manage scale. If the event provider sends you a lot of events at once, you have to make sure that your API endpoint can scale up and accept all of that traffic. So can we do better than this? Well, within AWS, we have a fairly new serverless event bus service, and it's called Amazon EventBridge. This was announced at the AWS Summit last year in New York. So this is a serverless event bus service that makes events first-class citizens across your entire workload. It can help you ingest and route events from SaaS applications, AWS services, and your own systems. It's not actually a completely brand new service. It evolved from CloudWatch events. So it already processes trillions of events every month. Some of the notable features of EventBridge include the fact that it's serverless, so there's no infrastructure for you to manage or provision. Scaling is handled automatically, and you only pay for what you use. It was launched with a range of native integrations with different SaaS providers, and there's many more coming. The traffic that comes into EventBridge travels internally on the AWS infrastructure instead of on the public internet, which can make things more secure. There's also no charge for events that are sourced from AWS services, and when you put events onto the bus, it costs $1 per million events. So how does it work? Well, on the left-hand side, it all starts with an event source. This can be any one of 95 AWS services, or your Lambda functions and applications, or SaaS applications. For SaaS application integration, there's a special resource that appears called a partner event source. And then there's event buses. So everybody has a default event bus in your AWS account in each region. It's always there. You can create your own custom event buses for your applications. And then there are buses dedicated to ingesting partner events. And then there are rules. So rules can basically use complex rule handling to figure out what's in the event and where then it should be routed to. So to give you an example of this, here's an example event of what happens when a ticket is created and it has an ID and it comes from a certain department. A rule might look like this. So a rule is just JSON, just like the event, and it might match on a source, looking for partner example.com 123. So in this case, the rule would match the event. You can also in rules specify multiple values. So if you wanted to match on multiple departments in this case, you could match on billing and fulfillment by using an array in your rule. Again, this would match. Well, here's an example of one that doesn't match because the rule is looking for a detail type of ticket resolved, but the example event shows a created ticket. So once you have your rules, that then routes the events to targets. And you can associate multiple targets with each rule to send events further on. So targets allow you to do things like invoke a Lambda function, or put a record on a Kinesis data stream or Firehose, or start the execution of an AWS step functions workflow, or start a task with ECS or Fargate. So that's the concept and the idea behind EventBridge, but let's take a look at how the code actually works. So to keep this simple, let's go back to the original example where we have an order service and an invoice service. We're going to put an event bus between them so it looks like this. Now let's put some code in there. So on the left-hand side, the order service, now what it does is it creates that event object, which is JSON, shown here. And this example shows that it has a source of demo.orders, and the detail type is a new order. The final line at the bottom, eventbridge.putEvents, is the method called to put the event on the bus. So you can do that with one line of code. When that code returns, that means that the event has been durably stored on the bus. On the right-hand side, you'll see the invoice service actually doesn't contain very much code at all because it's actually agnostic about where the event comes from. It simply receives the event and goes about its work as it would have done before. So the important thing here is the rule. The rule defines what happens. So this example is written in CloudFormation. For serverless users, you can also use SAM. The key things to notice here are that it's matching on an event pattern where the source equals demo.orders and the state equals created. It then defines a target of the Lambda function, the invoice service function in this case. So if you look back at this, the order service is generating the event of a new order. And then on the right-hand side, the invoice service is ready to pick up the event when it's routed there by the rule. So earlier I talked about the difficulty of adding new services in orchestrating workflows. So how do you handle adding a reward service with an event bus? It's actually as simple as adding another rule. And that's very similar to the last example, but the target is different. So by adding this rule, the same event pattern will now trigger a new target, in this case, reward service. And if we wanted the reward service to be triggered by a different event, we simply change the event pattern. So with events, it really is very simple. Now, recently, the EventBridge schema registry was launched, and this allows you to discover, create, and manage open API schemas for events that are flowing through your workflow with EventBridge. You can find schemas for existing AWS services and create and upload custom schemas or generate a schema based on events for the event bus. For all schemas in EventBridge, you can generate and download code bindings into your IDE, and that will help you quickly create a code to help you build new applications based upon those events. So in this talk, we covered a few of the common challenges of managing complex microservices, both in private applications and across third-party systems. Decoupling with APIs and webhook mechanisms tends to lock you into a more rigid, more complex and monolithic state, even in separate services. An event bus can help you keep these services decoupled, even as your systems become more complex, and with new versions of those services. We saw how the happy path works well, but handling error states can be really difficult to orchestrate. Event buses can help you manage those errors across complex workflows and help ensure that your service teams remain decoupled, only listening to the events that they care about and being responsible for the events that they're creating. In synchronous APIs, the availability of the entire system can be impacted by the failure of any single service. So moving towards an asynchronous infrastructure based around events allows you to create more resilience in your architecture, and with the right architecture design, can improve availability. For third-party integrations, I showed how webhooks are better than polling, but they come with their own challenges. So EventBridge offers SaaS integrations with a growing number of partners that can treat new data in these systems as events. So for a collection of code examples, blogs, and videos showing how to use an event bus, go to the link on the screen, s12d.com/eventbridge. I think that events can really make complex architectures much more resilient and easier to maintain. So thanks very much for listening to this. My name is James Bezic. I'm a DA with AWS Serverless. I'd be really happy to answer any questions that you might have.
Oh, thank you so much, James. It was a very nice presentation about the EventBridge.
Thank you.
So I see that we don't have a question from the audience, but myself, as I promised at the beginning, I have some question from you. So I'm very curious about all of these event services. So when I can make sure and how I can decide which service I will use for the event. For example, let's say I will use SQS like queue. I will use SNS for a topic, or I will use EventBridge, and when I am going to use EventBridge.
Yeah, great question. I hear this one very frequently. So there are three services. You have SQS, SNS, and EventBridge. SQS handles queues, SNS is a pub subservice, and EventBridge is an event bus. And in some respects, they have similar overlapping functionality, but actually, once you start looking at what they can provide, they're all a bit different. So the most obvious difference is that SQS, being a queue, that's functionality that's not available in either SNS or EventBridge. SNS also has a different range of targets, including things like mobile addresses or HTTP endpoints, and can deal with up to millions of subscribers, whereas EventBridge tends to only deal with smaller numbers of targets. But the really exciting thing here is you can combine these services to solve different problems. And it's something I recently blogged about on the Compute blog. If you have a look online, I've put some examples out there. But really interestingly, you can take SQS and combine it with EventBridge. And that's a really simple, low-code way to add resilience to your workflows. So if something goes down or there's an outage somewhere in your system, the messages are then stored in SQS. So even though these systems are all part of the messaging architecture that we provide and do have some similarities, they have very different features in terms of how they can be implemented in your workload.
Oh, thank you so much. They're really awesome and useful answer. And I have another question as well. Which services can send the events to EventBridge? So there are a couple of services features that can send all the events.
Yes, so the goal really of EventBridge is to make it so events become first-class citizens within your infrastructure. And so pretty much anything within AWS can generate an event of some sort. Now, some of these services have native integrations with EventBridge and can directly send events to the bus. Ones that don't have that native integration, you can still ingest the events via CloudTrail. So for example, if you want to pick up events from S3, you can use CloudTrail to pick up those events directly into your bus. But it goes beyond just what's available within AWS. So if you look at what's provided with SaaS providers, people like Datadog or PagerDuty or Auth0, they can also generate events that appear directly in your AWS account on these partner buses. And of course, you can generate events from your own applications, whether that's Lambda functions, EC2-based applications, or whatever you might have. So really anything within AWS has the ability to create an event that can then be put onto the event bus.
Thank you so much, James. Thank you so much. It was really nice presentation about EventBridge.
Great.
Definitely, I'm going to learn more about EventBridge. I'm going to do some tests to understand much better. So thank you, and see you in the next session.
Yeah, thanks very much. And if anybody has any questions, please feel free to reach out to me. My contact details are on the screen. And also take a look at serverlessland.com. We've put a lot of different examples, blogs, and code that can help you discover more about AWS Serverless. Otherwise, thanks very much for inviting me. I've had a great time. I hope everyone enjoys the rest of the day here at AWS Community Days Amsterdam.
Thank you, James. See you next time. I hope I will see you in the present.
Absolutely. Take care.
Bye.
Bye.
Welcome back. Hope you enjoyed your short break. It's only 10 minutes. I'm the guest host right now, so Zamira is running this whole stream all of the time. So for the people that are already there since the beginning, I hope you enjoy Zamira as a host. I'm the guest host right now. That's because the next speaker will be Zamira. I know Zamira for more than 2 years now, I guess. She moved to the Netherlands and is one of the AWS community heroes and also one of the APN ambassadors working for Mobiquity. Zamira, please join me here on the screen. You're managing the studio. Hi, good to see you.
Hi, Martin. Thank you so much. Yes, now it's my turn, and I'm so I'm so nervous. So because I like it's the first time that I'm doing both hosting and presenting.
It's going very well. So you can remove me at your slides. I will take note of all the chat messages, and at the end, I will ask you some questions from the audience. So see you back in 20 minutes.
Yeah, thank you so much, Walter. Let me share my screen. Welcome to my session. I'm Zamira, the presenter of today. So I'm going to introduce myself a little bit differently today. I started my career many years ago when the AWS console wasn't rich like today, but there was only some couple of services like EC2, S3 bucket. And today, if you see AWS console is a bunch of services, you have really difficult to find all of these services and features. I'm solution architect with more than 10 years of experience designing, implementing a critical and complex solution with AWS for a middle and enterprise company. I just joined Mobiquity last year as solution architect, helping our customers with their digital transformation. And as you see this sticker, this was the first when I started my career so many years ago. And now you see my laptop is a lot of sticker and a lot of services that I know from AWS. So this is my laptop tell everything about me. So what I'm going to talk today, I'm going to tell you guys about the concept of control tower. And I'm going to take some step backs and I'm going to share with you this experience. And this is really my example on how I experienced it, the cloud journey with AWS. I'm going some step backs and just through the journey, I'm going to show you let's say this cloud, the journey was very painful, and I'm going to explain you why could have done differently if I can use control tower. I'm going there. Let me present this example. So in 2017, I was working in consulting company. And during this time, one of our customers asked me, "Hey, Zamira, can you help us? Because we don't have experience on AWS. We don't have experience in cloud in general, and we want to migrate some services, some application from on-premise to AWS." Yes, of course, I'm here for that. So I'm here to help the customers. And they have just a couple of applications, just they wanted to move to AWS. I started to create the first AWS accounts for them. And I just migrated lift and shift their application in the beginning. And it was super okay, very easy to do that. And in 2018, this customer came back to me and say, "Well, Zamira, we really like this cloud and we really like scalability and everything works. So now we want to extend and we want to add more automation and we want to have more AWS accounts because we have some other departments and we want to have some other solution. We want to add monitoring. So can you help us with that?" Yes, of course, I can do that. And we started to adapt, let's say, the first solution, me and other guys that were working in the same team, to create and to extend all of this and to set up the organizations in 2000. And what's happened in 2019? So, wow, this customer was increasing and was being so big, and he has a lot of success. And he's having a lot of success, and he asked it again us, so can you help us to move and to increase to increase our application? We want really to have more application in cloud, and we have other departments, and we have also other customers that were helping. They want to go in cloud. They have machine learning, they have AI, they want to do disaster recovery. Probably they are using containers. And we have customers with thousands of AWS accounts. And I say, oh my God, this is really painful. So we have to create all of these AWS accounts manually, and we can create some tools, but and we have to do centralized login also. We have to implement also backup story. We have to organize all of these accounts in some way, and honestly, was really painful. Let's say in 2017. I spent like 100 hours, and in 2018 I spent around 500 hours, and in 2019 I spent probably 1,000 or 2,000 hours, and really, it's a lot. It's a lot, and you know why? I really asked it myself at this time. So, do I have something that flow me around, kick me, or something like that, so that all of these problems will allow me? And of course not. I do not have. But how I can have done this differently if I could have some technology, if I can have some solution to help me to organize all of these accounts and solution much easy and in secure way. So here we go. We have a control tower solution. So control tower, for all of you that don't know, the names comes from airplanes, and a lot of airplanes. So basically a control tower is going to manage the traffic of airplane in the way that this airplane doesn't crash, right? But here in AWS, control tower doesn't manage the airplane. So what control tower in AWS do is a managed service that allow you to set up in a easy way all AWS organization, to set up all AWS accounts in secure and applying some baseline. So some important capabilities of control tower are: 1, identity and access management; 2, compliance and guardrails; 3, account management; 4, security and governance; and 5, centralized login. We have really to remember this, because when I set up all of these things, it was really painful. So I'm going to explain deep dive on all of this. So when we talk about security and governance, identity and access management, control tower allow you automatically and give you automatically, when you set up control tower, a single sign-on URL in the way that you can access all AWS accounts. And this is nice because not only give you URL, but you can customize this URL, and you can remember. Imagine the first situation that I have thousands of AWS accounts, and when you create a new AWS accounts, all of these accounts give you like a new URL. Can you remember really all of this URL? But not only, so there are users and groups that you can set up in a master account where is a single sign-on. So remember this, that when I have all of these accounts, you have to set up a single user for each account. Let's say we have thousands of accounts, thousands of users. That means we have to find some third-party solution to save in security way user and password. But when we have a URL and when we have a single sign-on, we can use only once. So remember that we don't need to create IAM users in each account, but we create only master account, and all of these users are managed by governance team. And you can always add the groups and add users to the groups. Another capability of single sign-on also are the list of AWS accounts. So you can have as many accounts as you want in the URL. That means you can add also the permission of the people of the groups or maybe the roles to that account. That means, let's say I have an operation guy, and this operation guy needs to have permission only in production, and I need to have permission probably in another account as well. And when he's going through this URL, he see only 2 AWS accounts with the right permission. And I have from the other side, and I have admin guide, and he had to have the permission to all of these accounts because he needs to governance all of these things. And he see the list of all AWS accounts. And the application, not less important, definitely, you can set up a user in single sign-on that is assigned to specific application. That application can be, for example, let's say you have Elasticsearch, and you don't want to create a user in Elasticsearch when this Elasticsearch is hosted, for example, in the account number 1, because it's going to be very complex. So you create a user in master account, and this user, you set up a permission to this user, and you assign this user to specific application. And you have a dashboard that is show you all the users, groups, permission, and accounts. What about security and compliance and guardrails? So guardrails are basically the security policy that you are going to apply to each account. So when Control Tower set up a new AWS account, automatically it's going to apply the security policy. So why this is important? Well, let's take an example. Let's say is a company, and you have a guy that by mistake someone is getting publishing let's say the data, or is moving the bucket that is storage of your data from private to public. And do you know what's happening if this data, that the private data, are going public? So your company, first of all, is going to have a privacy breaches. And the second, your company is going to the bad news, is going to the news. And this is not really good news, it's going really to the bad news. And this means your customers are not trusting you anymore. And they're not trusting you anymore because their data are public now. And where their data are public, they are going to leave you. And so this is very, very important. With Control Tower, give you the possibility to make to apply the security baseline in which account. So make sure that this solution, this account, this services, and this feature are compliant. But how? So I mean, okay, yeah, we talk about the compliance, we talk about, and we want to make sure that our data are private. So how these accounts speak together? How they have a permission? How make sure that this Control Tower grant permission? So when you set up the organization, and when you set up accounts, automatically Control Tower allow the possibility of give the possibility to create automatically cross IAM roles. These roles grant specific permission between AWS accounts and make sure that these accounts talk together. So that, let's say we have a security account and we want to make sure that we get notification in real time. If something happened in which of account, or something happened in service. And you know what I said before, we don't want to go to the news. So if we don't want to go to the news, we want to make sure that we have the right permission, that we get the notification if our services is not compliant. But from other side, we have centralized logging, and we want to make sure that all our we are collecting all the logs from application to the centralized logs, when our team can analyze all of these logs. Another important things about Control Tower is give you an AWS organization and allow you to create a group of AWS accounts. And which way? Let me give you an intangible example. I work at Mobiquity, and we use AWS account, obviously. So we are AWS partner, and we also have customers. We have customer one that have probably 10 accounts, and we have customer 2 that have 15 accounts, and we have customer 3 that have hundreds of accounts, and we have a lot of customers. And we want to make sure that these customers, first of all, don't speak together, and want to make sure that the security of all of these accounts, so all of these accounts are secure. So what's happened in organization? So we have these groups of accounts, and we apply automatically the policy to specific group. Let's say we have in the Middle East the bank, and they are asking us to apply some security in place to their account. So we very easily go into the organization, go into that customer, and apply security only to that customers. And we have another customer in South Africa that is hospital or something else. They have completely another security policy, and they want to apply this security in their account. So we do the same logic. This is the easy way to organize all the accounts and isolate the account by each other. So account management. Well, we talk about security, but how we can provision all of these accounts. Remember when I was talking in the beginning, so how much time I would take to provision thousands of accounts manually. And let's say in the future, probably you will have not 1,000, but 20,000 of accounts, how you can do it very. So only to set up one account at least take like 10 minutes. But with Control Tower, you can set up a new account only in 1 minute. What this means? So through Service Catalog, you can decide, so these customers to have some permission, and you can decide not only the customer, but also your group or specific people to launch and to create a new AWS account. What is important, and I really want to highlight, is the portfolio. So you can decide how it will be the maximum of the budget to this account. What this means? Well, let's say, so I'm going really to give you an example. This is a real story. Friends of mine, he had the startup, and he hired a lot of developer, and one of developer by mistake published their credentials. Only in 2 hours, so they saw the billing was like $40,000. And this is really, crazy, especially for startup, how you're going to pay all of this money. So it's if you don't have any limitation of AWS accounts, or let's say someone is going to steal you the PIN card, and they are going to pull, and if you don't have any limitation your PIN card, they are going to pull from ATM all your money, and you are broke. So what's going on in this situation? So this is why it's very, very important to have limitation on a new AWS account. Let's say you want the developer has only €1,000, and after 1,000 you get a notification, you will stop probably you can extend. What about centralized login? This is important as well, and you want to find some solution. So Control Tower give you automatically the possibility to collect all the logs cross account and cross regions using CloudTrail. So CloudTrail is a service that collect the history of all the action that's happening in AWS. Probably can be through the AWS console, or probably can be through API, so really doesn't matter. And why is it important to collect the logs? Well, it's important because let's say you have a website tomorrow and you are selling products in your website, a website crash, right? So the customer are not able to buy at this moment because your website is down. So what's happening if you have this website cross account, and what's happening if you have all these services cross region? So you have to go probably in each account to analyze the logs, and it's not really easy. So when you have only one place, all of these logs from operation point of view, you can filter by account, you can filter by application, and you can analyze the logs very, very quickly and very fast. And this is very important, especially when you have RTO like less than 2 hours. And if you don't resolve this problem in less than 2 hours, that's mean you are going to pay your customer. And how much will cost all of this solution? This is really, really a great solution. Give me a possibility to set up AWS accounts, to set up the rules, to set up everything. So this give me, so let's say Control Tower. Control Tower doesn't cost anything, it's $0. And this is, wow, incredible. So only some costs about let's say about Control Tower are the feature or the services that are part of a landing zone solution. So compliance configure only in 1 month costs like around $3. Storage is 3 buckets. When you collect all the logs, cost about $1. And there are some tax for each AWS account, cost about $1. Well, I'm taking back to you guys, and remember what I said in the beginning, how much time I take to set up all of these AWS accounts. Let's say you need around 3 months, and you have a guy that had, let's say, salary monthly 80K, and he needs quarter of the year to set up landing zone, and that's mean this landing zone is going to cost you around 20,000, right? So what you are going to choose, 20,000 or for year? So for year you can choose, right? And so this service is wonderful, and there are always some pro and cons. So this is the pro is easy setup. Only in last 2 hours you can have a full landing zone with capability of AWS organization, accounts, security in place, and all of this. And the nice thing is that a lot of company ask me, well, we have already organization, we have already single sign-on. How we can make sure that we don't need to set up from scratch? Control Tower now support the existing organization using single sign-on. And support versioning as well. Let's say you have some baseline, and you want to add some new feature, you can apply so as many times as you want. And the account can scale, so you can add thousands of accounts now, but you can remove it in just 1 minute. So as you know, this service is completely new, was launched in 2019, and some cons is no API available right now, and is not available in to all regions. And this is the last slide that I have for today. Let's say we have a complex approach, and in complex approach, just to summarize everything, I'm just 1 minute bit of time. So just to summarize everything, in Control Tower cover all the governance services to set up in easy way and very, very fast way. And make sure that security is in place, and make sure that the login is in place. And you can add as many accounts as you want based on your requirement. And this is my presentation. So thank you so much. You can find me on social. You can find me, you can send me an email if you want to know more about Control Tower and the solution. So thank you so much.
Yeah, thank you so much, Zamira, for doing your talk. It was great. I actually forgot to mention that even this talk is selected anonymously. So Zamira sent her abstract. I anonymized everything. It was rated. So also this talk is really based on anonymous voting. We actually have one question, and we do have a few minutes time left. John Heck, he asks, could you go into more detail on how the security team receives alarms in real time?
Oh yeah, so I went very fast to that slide. So yeah, So basically, Control Tower give you the possibility to get the notification in real time in this security account. So in all accounts that Control Tower apply and all accounts that Control Tower creates, make sure that this security policy is going to apply to these accounts. And how these notifications are getting in real time is important. So there are a couple of services that work together as solution. So let's say, for example, you have an S3 bucket that is going to be non-compliant, and you have AWS config rules that this change the status of the service as well. We have a service that is not compliant right now, so it's going to send notification to Lambda function, and Lambda function elaborate this request and say, it's true, we have already a service in this account that is not compliant, and through the SNS topic, I'm sending automatically the notification to security guy. That could be probably via email or via Slack or whatever kind of integration you can do with third-party tool.
I think we lost the last sentence, but do you still hear me, Zamira?
Yeah, can you hear me? Sorry.
Oh, okay. Yeah, it's working. No worries. Thanks. I don't think John is still online because he's not replying. But thank you for your answer. There's not much time left for another question, but feel free to reach.
I just went 2 minutes.
No worries.
It's so difficult to match the time live.
Yeah.
I see that we have less time to present the next speaker.
Yeah, in about 4 minutes, the next speaker will be announced by you. So you continue the track. You have a tight schedule and a very busy schedule ahead. So thank you on my behalf and on the organization. You're doing a great job. For the audience, I hope you enjoy the further sessions, and hope to see you in the closing keynote as well.
Thank you, Martin.
Bye.
Bye. We are back. Yeah. So we can't wait now for the next speaker. This is the last speaker for today. So welcome, Mark. I know that you are in USA, and what time is there now?
Yeah, I'm in Canada, and it's just before, it's 11:10 in the morning, so not too bad.
Oh, okay. Oh, sorry, in Canada. Yeah, that you are right.
Other side of the ocean. It's all the same at that distance.
Okay. So thank you so much, Mark. And I'm going to put directly so I'm going to hand over to you. And you are AWS community hero. Sorry for that. And you are in the same. Okay, great. I'm going to hand over to you. So good luck.
Thank you. No problem. Let me start my timer so I make sure I'm on time here. And thanks to everybody for joining. Very, very much appreciate it. As you can see, I have a very long, like Fiona Apple album level title here. Reality is, I want to talk about building in a very, very real way. And I think that's really important for everybody to acknowledge that at the end of the day, let me just get going, you're going to make mistakes. No matter how hard you try, no matter how well prepared you are, you're going to make mistakes. And that's absolutely okay. There's nothing wrong with that. Some of these mistakes you probably could have seen coming in retrospect. Some of them you had no ability whatsoever to avoid. They were just unpredictable, some of the crazy chaos that we deal with every day in the AWS cloud. And part of that reason is simply just the vast number of services and features we have in the AWS cloud. I think anybody who's been building in the cloud for more than a year knows that we're about to hit the mother load at the end of November 30th. AWS reInvent 2020 kicks off online, and we're going to get just an absolute flood of new services. In fact, that normally starts 3 weeks ahead of reInvent. And, the reality is you cannot keep up. It is the vast majority of my job to try to keep up, and it's just crazy impossible. And that's part of the wonderful part of the AWS cloud. We're always getting new features. We're always getting new services. And that just means there's so much complexity. There's so much possibility that you're probably going to make mistakes. And that, like I said, is absolutely okay. The problem is, especially for those of us who work in large organizations, is that kind of leads naturally into what we like to call best practices. Now, personal opinion here, side rant, which is most of this talk. I'm not quite at Corey Quinn's level of ranting and snark, but I'm aspiring. I hate with a passion the term best practice, because it implies that there's only one way to do it. It implies that this is the way you should be doing whatever you're trying to accomplish. And I don't think that's true. I think there's a multitude of ways to do it. And really what you're missing there is context. Why is this the best solution for this circumstance? That's really key here, for this circumstance, because all the time you have different circumstances, you have different challenges. If you were lucky enough to tune into Zamira's talk just before this one, she was explaining that she has customers who have a couple accounts, a couple dozen accounts, to hundreds of accounts. And if you're dealing with account management, each solution you're going to pick is going to be different based on the context. So there's no true best practice. There's what's well for now. And that really leads to the main thrust of this talk, which is the AWS well-architected framework. Hit me up in the chat. Let me know if you're familiar with the framework, and hopefully you're applying its principles. This is a collection of knowledge, of wisdom that is hard won. It is built over the years from AWS customers. Tens of thousands of AWS customers have contributed. The AWS ProServe team, solutions architects, and the community at large. And it is a wicked, awesome, amazing repository of knowledge that really is trying to teach you some core principles. But you may have noticed in the AWS console, there is actually the well-architected tool. You're seeing it right here. And if you dive in, this is security section, question 4. You'll notice that it gives you this prompt. It says, configure service and application logging. Now, that sounds a lot like a best practice. And you could consider this a best practice, but here's why I don't like that term again. I told you I was going to get ranty. The reason I don't like that is because what are you going to do after you turn all this on? Yes, it's a fantastic idea to turn on CloudTrail, CloudWatch, GuardDuty, and Security Hub. But what are you going to do when CloudWatch generates an alert? How are you going to react to that? What is your team going to do to handle that information? Same with if you see a finding out of GuardDuty or Security Hub, what are you going to do with that information? What's the next step? What's the context in which you're going to use that? Because it's one thing not to have these on, that's bad. It's another, you know, to turn them on and then not be able to do anything with the information. I think that's worse because my experience, I'm a security guy at heart. My experience in security, it's easier to say we didn't have the capability of seeing that issue before it happened than to go to your board and say, well, you know, we had an alert sitting in our inbox that told us exactly what was going on, but we didn't do anything with it because we didn't know how. That to me feels worse. So the idea here is to drive around some core principles, and each of these principles are aligned to one of the 5 framework pillars. So we have operational excellence, cost optimization, reliability, performance efficiency, and security. Now, each of these have their own dedicated white paper within the framework. There's an overview paper and then a deeper dive into each one of these pillars. But don't think for a minute that they're separate. They're actually completely intertwined. You can't have one without the other. You can't have security without reliability. You can't have operational excellence without, you know, diving into cost optimization and performance. And as much as you want all of everything, right? I want an easy to run, super cheap, amazingly reliable, performant, and secure solution. You're never going to get there. That's just the reality. You're going to have to keep evolving and changing. And that really brings us to the core of the framework. And those are the principles. So there's 6 principles here. And the first one is use on-demand resources whenever possible. So idle is your enemy. You don't want stuff that you're paying for that's not actually working for you. You want to make sure that everything's automated. If you're typing it in, it better darn well be into a script to automate it the next time and not to actually make a change because then you're just not moving yourself forward. You're not improving your daily work. You need to test regularly and at scale. And you're going to see an example of that in the story I'm about to tell you. And, you know, if you've ever dealt with AWS, you know they're data obsessed, right? And that's because they've really taken to heart, this principle about fact-based feedback loops. And the idea here is that you have a really quick way to tell if what you're doing is worth doing. Really that simple. And of course, that leads to constantly evolving your architecture and practicing. So it was implied in what I told you earlier of having the alerts. What are you going to do with them, right? And if something falls over, how are you going to pick it back up? So these are the 6 principles. Principles around the well-architected framework. And they're really about teaching your team how to constantly question and improve and move forward. Nothing is stagnant in the cloud. But before I get to the story, I really want to underline this. We are doing a blameless postmortem here. I'm not going to mention the specific team or the company they work for. We're not going to judge. They made decisions that made sense at the time, given their circumstance. And I think this is a really key element of DevOps philosophy. It was brought up in the Phoenix Project and reinforced in the Unicorn Project by Gene Kim, both fantastic books. And this idea is, you know, let's look at the work and let's learn from it and move forward instead of casting judgment. So this team was building a streaming video platform. They started last year when the pandemic hit and things started shutting down, and they were looking to fill a very specific niche. They wanted to sell access to these streams, and none of the big platforms met their needs for cost, for privacy, or to tailor what their small team could deliver. So they needed a custom solution. Now this isn't crazy. It's pretty straightforward of a design, and this is, you know, sort of what they were aiming for when it comes to the end user. We've seen this 1,000 times. You can slap any number of logos on here. You've essentially got a web browser that's delivering live video, and you've got a side panel that's delivering live chat. So authenticated users come in, they can watch the stream, they can chat about it. I don't know, kind of like we're doing right now, right? Very, very similar. It wasn't this platform, though, just as a caveat. I won't name the names, but I'll tell you who it wasn't. It wasn't this. So this is the setup, and this is the design they came up with. So the users would access an application load balancer that would hit just one big pool of EC2 instances that were in a scaling group that were running this custom app. That app pulled from S3, and it made transactions back and forth with DocumentDB, which is the MongoDB repository, or MongoDB compatible repository run by AWS. And of course, they were using CloudWatch to monitor it all. This is a pretty solid solution. There's nothing here that you kind of go like, oh, what are you doing? This makes sense, especially when you think of, you know, this is a couple people. This is 2 to 3 people who were building and running this. So they've simplified it out to optimize what they can actually deliver to their users. Now, the challenge here is, of course, is that video and chat are running on the same instance pool. You can probably see where this is going, but we're going to walk through it anyway because it's worth learning the lessons. They had metrics around the request response time, sort of end-to-end for the user in seconds. And when they were running their tests, anywhere, you know, between 10 to 50, and I've normalized out the graph to make it easier to get the point across, anywhere 10 to 50 users, they were seeing really great performance, right? They were having somewhere between, 1 to 2.5 seconds for a user to get up and running on the platform, which is not bad. That's a tolerable experience. It's into that zone that the Nielsen Norman group, who are fantastic UX researchers, say is, you notice that you're waiting as a computer, but it's acceptable. If you can go sub-second, then it's imperceptible to the user, and it's just a much more pleasant experience. But over a second is not too bad, as long as, you're keeping under this 2.5 second. So as they started, they ran their tests, they said, great, they sold tickets to their first event. And as that event started to spin up, they noticed they got way more than the 50 people. Now, here's where the first fall down happened, is that they sold tickets, so they should have known how many people were coming. That's a direct correlation, right? You sell 100 tickets, you can expect 100 people. But what they didn't expect was the day of the event, sales really, really shot up, and they were so busy getting ready, they never actually went back and checked that, because sales was another part of the team, somebody else's responsibility. So as they start to roll this out, they see over 100 people are there, and they start to see a spike in response time. We're getting closer to the average of 2.5 seconds instead of like 1. Well, that's a problem. Well, this event was amazingly popular, which is a great business problem to have. But when they got to 1,000 users, things started to get really bad. 10 seconds on average for response time. Now, I don't know about you, but the last time I waited 10 seconds for a web page to load was probably 1995. Right? Like, just not something we're used to in this day and age, with ubiquitous bandwidth and great speeds. So 10 seconds, users started complaining, they started dropping off, they started abandoning the stream, even though they had paid for it, and of course they were really grumpy. And as the users continued to spike in and stream into this to get access to this stream, things just got out of control. It got into this really odd loop where their auto-scaling metrics weren't great. So as the demand requests came in and spiked up, they would spin up more instances, but then those requests would be abandoned, and the auto-scaling group was trying to scale them back down again. And so they got stuck in this bad place, and nothing was responding, and the whole thing essentially tanked, and they were scrambling, trying to figure out how to serve their users. So they did not test regularly at scale. They tested, which was great, but they only tested with sort of less than 50 people, which they thought would be reasonable. Like, hey, look, this scales. It should scale the same way on up. That's what auto-scaling is for. But they didn't realize they needed to pre-warn this if they had spikes in demand, that this kind of thing would happen. So this is a problem. And it reveals the fact that they never practiced what would happen if things died. They were scrambling to make a status page. They were trying to reach people on Twitter. Just in general, not great. So if we look back through the idea of the lens of the framework, we see operational cost was pretty low, or operational excellence was pretty low. The cost was solid because it was tied to actually paying users. Not at all reliable, not at all performant. And the security was okay, because they just had that one set of instances to monitor and to lock down, to do patches and upgrades and things like that. So not bad. But they knew they had to do better because it wasn't a successful stream. So they split. That's the first thing they did. They split their chat and they split their video. They used the same app. They just didn't use half of it. And they used the ALB to route video to one and chat to the other. And this made a huge improvement. Simply diverging concerns made a big improvement. Now, the problem they still had with the video scaling up, but people were able to actually log into the chat. They saw the interface. They were able to complain, and complain they did in the chat about how bad this was, but at least it wasn't completely just a crash screen and throwing out errors left and right. But it still wasn't good enough, right? So this was a good evolution, but it was just one step along a path that they needed to be taking. So what they realized when they had split this, well, hey, wait a minute, do we really even need EC2 instances to serve out the video? And it turns out, of course, they didn't. They have another EC2 instance that the streamer was actually streaming to, but they could drop that instead of into a pool of EC2 instances to serve out. They could drop it into an S3 bucket and use Amazon CloudFront in order to push that out to the users. And now they've got a really slick solution because it's far less overhead for operations, and it actually turns out to be less cost. So they've evolved the architecture, which is great. They've moved away from having these instances run it. And I would argue here that even though they were using on-demand EC2 instances, they've actually taken that principle of using on-demand resources to the next level. So instead of paying for EC2 instances that are only used 70% of the time, for CloudFront, they're being billed for every gig that's going out, which directly ties to a user that's being served, which directly ties to a ticket that was purchased. So that's a really good use of the new architecture. So here we see operation stays about the same because they still have some instances to manage, but cost is improved, reliability is improved, performance is improved, security is about the same. So let's keep going down this path. They realize, hey, wait a minute, breaking this apart is really, really useful. We're seeing some huge advantages to breaking this system apart. And so they went even further. And they realized that chat app doesn't actually have to run on EC2 instances. Turns out that AWS has sort of a jumpstart in an example project on the blog that shows how to deliver a web chat through AWS Lambda functions and AWS AppSync tying back to a DynamoDB table. So here we've gone to a full serverless solution to deliver the chat part of their application. In fact, they've moved this entire solution inadvertently into a serverless solution, which has greatly reduced their overhead and has made it a lot easier for them to scale and a lot easier for them to make sure that it's running and keeping the lights on. So they evolved the architecture yet again, right? This is our 4th or 5th evolution, and they're getting closer and closer to a solution that best fits their needs. Now, they are currently exploring going even further, which is crazy. They are looking at the new Amazon Interactive Video Service. This service dropped earlier in the fall. And essentially what it is under the hood, it's a CloudFront and an Amazon S3 and a few other things stitched together. But from a user perspective, from a builder perspective, you push video into an endpoint that you built, and then the SDK gets dropped into your app and delivers that video to your users. So they've taken even the little bit of overhead they had with CloudFront and that S3 bucket and eliminated that. So all they have is the interactive video service, fired up an endpoint pushing there, and that makes the solution even slicker for them. That's a great principle. We're following the principle of automating all the things, right? They've gotten rid of even more of their operational burden. So operational excellence is through the roof. Cost optimization is great. It's reliable. It's performant. It's more secure because they've gotten rid of those instances. Remember, if you have an instance or a container, you need to patch it. You need to update it. You need to constantly monitor it for a variety of security issues. But if you're running a completely serverless solution, that's AWS's problem, which is a wonderful thing to hold on to. So if we compare that to where we originally were with the solution, we've made strides in all 5 of the pillars, right? This is a great work by the team. Through constant evolution, they've made strides in all 5 of the pillars and come with a much better solution for their users and for their business. This is a huge win. So what are our takeaways here? What's the key to figuring out how this works, right? Because isn't this just what we all do anyway? Well, kind of, but there's a little more formalization around it. We're using the framework to help guide us through here because the AWS well-architected framework is really about finding the best solution for you at the current time. So if you see someone come out of an AWS well-architected review, which is something you can do with an APN partner or on your own, and they're like, we passed our review, we're well-architected. Yeah, for now. But something's going to change, and if it's you changing it, you know about that, but we know reInvent's coming, and there's a whole bunch of changes coming from AWS. You are going to have a different answer to what's well-architected tomorrow than you did today. In fact, that's one of my absolute favorite parts of AWS reInvent is that something that I will have this, what I think is a lovely, elegant hack of, 50 lines sitting in a Lambda to solve a problem is now a checkbox after reInvent, which is great. And that's the idea of the well-architected framework is you keep finding the best solution for any point in time. You continually evolve forward. We do that by applying those 6 core principles of the framework itself. It's not a list of best practices. Despite your impression of the AWS well-architected tool, that tool is a prompt to help you apply these principles. And the principles are using on-demand resources whenever possible. So we want to make sure that we're not paying for idle time. We don't want to spin up stuff just to have it sitting there in case we need to use it. This is why serverless solutions are such a great fit. And when you're looking to design a solution, you should start with serverless, go to containers if you have to, go to instances if you absolutely must, because you want to apply this principle of using on-demand resources, and that applies throughout the entire AWS cloud. Similarly, automate everything. Don't do things by hand unless you're just testing out the proof. And as you're doing that by hand, create the automation as you go. You should not be doing things by hand at this point because it's just so much easier to automate it. Almost everything's available through an API or a CLI command. Take advantage of that. That makes testing regularly and at scale very, very easy. You have relatively, essentially infinite capacity in the cloud. Take advantage of it by testing a real duplicate of your production environment to make sure that if it's going to blow up, you know how it's going to blow up. If it's going to fail at a certain level, you know because you've tested it in an isolated way and not impacted your users. And again, this concept that we keep hitting on, feedback loops that are data-driven. So you have an idea, you set up some metrics around it, you test it out, and you learn from that. And that creates this constant evolution of your architectures. And as you're evolving, don't forget about that operational piece. Understand how this thing works in practice, how you're going to use it, how you're going to have processes around responding to alerts, responding to issues. And so that's not all bad. That's just working through, right? Professional football teams don't just take the pitch. They practice too. You are just like that. You need to practice and work it through. Remember, the framework's organized around these 5 pillars. They work together. They're not isolated. You need to make sure that they work together to have a solid solution, but it's really at its core. It's this constant idea of having an idea, trying it out, learning from it, adjusting and repeating, and just keep on going, because that's how you're going to learn. That's how you're going to evolve and get a far better architecture than when you started out with, just like we've seen in this example for the video streaming platform. Thank you very much. My name is Mark Nunnikhoven. I'm an AWS community hero. I'm also the Vice President of Cloud Research at cybersecurity leader Trend Micro. You can hit me up online at marknca or at my website, markn.ca. And I think we still have a little bit of time for questions. So Zamira, is there any questions kicking around?
Yeah, thank you so much, Mark. It was a really nice presentation about well-architected framework and all the 6 pillars I really enjoyed. So how you can really start to have a well-architecture and well-designed when you start, especially with new in AWS and when you really don't have experience. So let me see, I don't see any question. However, I have myself a question for you.
Okay.
So, Mark, I'm really curious, why would I want to use the AWS well-architected framework? Let's say, what really the advantages of using this framework instead of, for example, probably I have a best solution architect in my team or in my company. Why am I going to use this tool? So what does this tool help me?
Yeah. And so there's 2 parts to that. There's the framework itself, which is some documentation, some white papers that help you apply the principles and understand the principles. Then there's the actual well-architected tool. And a lot of people go into that tool in the console thinking like, this is going to, I'm going to point it at my CloudFormation template and it's going to verify that I'm following all these good ideas. And really what the well-architected tool is a way to have a discussion with your team. And I like how you phrase that, because a lot of teams do fall back on that sort of that one person who's like, oh, you know your stuff, we're going to come to you all the time. And that's okay at the start. But really what you want to do is you want to increase everybody's cloud fluency. That's a term that Forrest Brazil uses from A Cloud Guru all the time. And I love it, so I'm stealing it. You want to make sure that everybody is increasing their knowledge of the cloud, and everybody is increasing their knowledge of what makes a well-architected solution, because then you're going to all move forward as a team. Right. And I really think of it in that team, in that sports metaphor, if you want, where you can't just have one person on a football team who's doing everything, because that doesn't work. You're up against a whole nother team. The whole team has to be at the same level, working together. And so the well-architected framework gives you that guidance of how to think and how to move forward under those principles. The tool itself in the AWS Management Console is basically just like a Git repo of discussion results. So as you go through and actually type in your answers, it will version it. And so you can tie it to the versions of your code and say, for version 1, here's the discussion we had, and we skipped this, we didn't do this, we thought about this, we moved here. Then for version 2, you keep going.
Right?
Yeah.
Okay, a really good answer. So it was very useful. And I have another question as well. How can teams start using a well-architected framework? So where is this tool? How they can start using?
Yeah, so if you just go to, if you search for well-architected in AWS, you'll land on the main page. It's aws.amazon.com/well-architected. And right there, the first thing to do is read the overview paper. It's only 6 or 7 pages, and it really just introduces the pillars. It introduces some of the principles and the ideas behind the framework. And then it's really just, I find it best used as a tool to start talking. So if we were working together, Zamira, I would say, okay, I looked at what I built, and I find like, while it, it seems to perform really well, there's so many things I need to do behind the scenes to make that happen. That's not really efficient from a performance perspective. So we're not getting that performance efficiency pillar in there. What can we do to move forward? And so it's really just a discussion starter. It's not a magic wand. I wish it was, but it's a way to help talk to each other on the same page using the same terms to move your solution forward.
Yeah, wow, this is really good answer. Thank you. And I'm very curious, and I have another question, Mark. Sorry for that, but I'm very curious. For well-architected framework, this tool is good, let's say, to be used only for enterprise company or for startup company, when this can be more useful.
I would say everyone. And because it is just about talking and thinking about how you build, I've found it useful for 3 or 4 person teams, which is what the example I was using in my talk. I've taught enterprise teams with hundreds of architects and hundreds of builders the same thing. So it's really not about the size of your shop. If you're building anything in the AWS cloud using any number of services, this is a really useful tool. And it's really about teaching that principles, because I think the biggest tragedy in the cloud, if I may, is when people just assume like, oh yeah, I know how to do this, I'm just going to do what I've always done. And you're leaving a lot of power and a lot of things that help you on the table and unused. So it's good for anybody and everybody who's building in AWS. Yeah,
definitely. Definitely, it's important to have always, or to start it always with in a good solution, because when you do mistake in the beginning, you have to pay in the end. But it was my example as well. So thank you so much, Mark.
Thank you.
I think that today we finished. You are, let's say, last speaker for the session of AWS Community Heroes and Amazonian. So thank you so much. See you in the next session.
Ja, dankjewel.